diddly-dum-dee-diddly-dum-dee-dum-dee. There ain't not been some clever bastards, lucky bleeders, lucky bleeders. Ain't not been some clever bastards, lucky bleeders, lucky bleeders. Ain't not been some clever bastards, lucky bleeders. There ain't not been some clever bastards.
I'm here near Durness in northwest Scotland. These striking buckled cliffs are made of Lewisian gneiss. This rock was once granite, formed deep within the earth, but over time it was transformed and metamorphized by intense heat and pressure, and this process squeezed and rearranged the crystals inside, creating these very beautiful and complex patterns we see today. These rocks come from an alien planet, a water world with no continents, as we know them, just low, flat land, emerging from an endless ocean. It was volcanic, with an atmosphere rich in methane, carbon dioxide and water vapor. There was no blue sky, but perhaps a greenish or yellow-orange under a very dim sun. And the only life were microbes, little green bacteria, that formed colonies in warm, shallow waters. Its year was roughly the same as our Earth, but it had twice as many days in a year, with each day only lasting 12 hours. Of course, this alien world is our Earth, but 3 billion years ago. Now, the revelation of how old these rocks are, indeed how old our planet is, has been a slow and methodical process. Precise dating using radioactive decay in these rocks only emerged in the 1950s. Inside the rocks are extremely tough and ancient zircon crystals, acting like tiny stopwatches where uranium decays to lead over billions of years, and it allows scientists to measure their age accurately. Before this technique, the best estimate for the age of the Earth came from Lord Kelvin, the Scottish physicist, a century earlier, and now he applied maths and physics to calculate how long Earth would take to cool from a molten state, and estimating the age to be between 20 million and 400 million years. His calculations were impressive for its time, but were limited by the lack of knowledge about radioactive heat sources inside of Earth. A century before Kelvin, during the dawn of modern science, Neptunism was the prevailing belief. It followed biblical tradition, suggesting Earth was a mere 6,000 years old. This is Biddulph Grange, a stately home built in the mid-19th century for the wealthy industrialist James Bateman. He loved fossils and geology and exotic plants, importing some of the first monkey puzzle trees from South America for his fantastical garden. His extensive rock and fossil collection is here in this exhibition. Despite the scientific progress of his time, Bateman was a devout Christian who wrestled with reconciling his faith with the science. Here, he arranged his collection to fit the biblical story of creation over 7 days, and it aligned with Neptunism's idea that the world emerged from a great flood, covering every mountaintop. According to Neptunism, granite, the foundation rock, was the first to precipitate from the watery planet. Granite was seen as God's foundational rock because it had no fossils, and then each layer of sediments above it was progressively younger, representing God's increasingly creative ways in making plants and animals. Neptunism, however, was vague about where all the water went, and explained the buckled sedimentary rocks as a result of drying out and local earth movements rather than tectonics. This is the National Portrait Gallery, a tribute to the great and the good Jews of Scotland. And this is James Hutton. He is largely unknown outside of geological circles, but this man allowed us to see forever. This is him painted in 1776, at the age of 50, and we see an older gentleman, respectable and established, but his genius was to emerge much earlier. Now the notion of what makes a genius has been greatly debated. Is it inherent? Is it something we're born with? Is it a product of environment? So I'm going to explore James' extraordinary life and discover a few clues as to what that elusive quality of genius is. And I'm going to start here in Edinburgh in the 18th century. Now, James was lucky to be born in Edinburgh on the 3rd of June, 1726. The city was a centre of learning, science and debate and education, and it's no coincidence that contemporaries that included James Watt the engineer, the philosopher David Hume, Adam Smith the economist, as well as a host of philosophers and poets, Robert Burns, were part of the Scottish Enlightenment, which had Edinburgh and Glasgow at its centre. This rational flowering came from a seed of Protestant religion. John Knox, a Calvinist minister and outlaw in 1560, instrumental following the revolution in Scotland between Catholic Crown and Protestant, set about ensuring a school in every parish. Reading for all was a priority, although this was for the benefit of learning Protestant scripture, and universal education for boys and girls led to a very high literacy rate in Scotland, higher than that of England and France. And people being people, once they learned to read, were quick to consume far more exciting texts than the purely religious. And Scotland had 3 universities in the 16th century and a 4th after the Reformation, here in Edinburgh. And it's here that the young James Hutton attended at the age of 14 to study humanities. He trained as a lawyer, but was much more interested in chemistry, and at 18 he studied medicine as a physician's assistant at the university. James continued his medical studies in the following years, first in Paris University and then Leiden in Holland, and returned sometime after the age of 25 to Edinburgh. And there he took up chemistry, setting up a company with a friend that derived an important industrial chemical, sal ammoniac, from soot. James commercialized the manufacture, utilizing the vast amounts of low-cost raw material from the city's chimney sweeps. And this venture gave him a comfortable income, and he was able to pursue other interests that didn't include medicine. He particularly enjoyed the company of his friends, discussing science and invention and philosophy, drinking whiskey, telling rude jokes, and frequenting the city's brothels. It was around this period that he was to father an illegitimate son with Miss Eddington. Now, although he funded the child's upbringing, he had no involvement with him or the mother, and it seems his wayward ways led him to yet another career change that doesn't appear to be of his making. James was born into a land-owning middle class of Scotland. His father died when James was just 3 years old, but the family possessed farms, the renting out of which sustained his mother and allowed him to go to school and then on to university. This family wealth was to be a burden, as it seems he was exiled from Edinburgh to manage the farm in the south. An exile he hated. He called it a cursed country where everything aspires to break my heart. But his fickle nature, or rather aptitude as a polymath, led him to learn about the latest thinking on agriculture and soil. From the age of 32 to 41, he threw himself into the science of agriculture, experimenting with the latest techniques in soil management, animal husbandry, and drainage. He experimented, and he recorded his findings in the spirit of the age of science. Now, a big understanding was that he saw soil as a living thing, a composition of both organic and mineral components, and he helped pioneer soil science. James noticed that the rains washed soil into his ditches, into streams, into rivers, and then into sea, a cycle of erosion, transportation, and deposition. The prevailing consensus at the time was that geology was formed in the great ocean, Neptunism. Now, James concluded that despite thousands of years of rain on his farm, the soil had not washed away, that it must be created to replenish what had been lost. Therefore, there must be some mechanism that recycled eroded material, a mechanism that returned sediments of the seabed to the tops of mountains. James did stand on the shoulders of other geniuses. He was influenced by a book published in 1740 by the Venetian abbot Anton Moreau, trained as a priest, but he pursued a life of scientific inquiry, which included fossils, geology, and importantly, volcanism. Now, for the Neptunists, volcanic activity was considered unimportant. Anton Moreau observed marine fossils in sediments in the mountains of Italy and proposed that they were laid in oceans and that the mechanism of lifting these sea floors was volcanism, having observed volcanic eruptions on the Greek islands of Santorini. This idea that volcanoes powered the change of Earth was called Plutonism, and it became a counter-theory to Neptunism. And clearly, James became passionate about discovering the true nature of Earth's geology. Now, after spending years on the farm, at 41, he was able to return to Edinburgh, freed of his rural exile, and able to enjoy the company of friends in clubs and bars and the brothels. And he actively engaged with leading thinkers of the Scottish Enlightenment, including mathematician John Playfair, who was to become a great friend, philosopher David Hume, and the chemist Joseph Black. Now, James was wealthy enough to choose his callings, but not wealthy enough to descend into a kind of hedonistic decadence. He became a shareholder in the Fourth Clyde Canal and was active in the construction project, with the cuttings allowing him to explore the rock strata of the area. As a businessman with his chemical works, he appears to have associations with factory owners. Now, a story from a bottle works left a deep impression. Sand had been melted in a furnace, but a technical issue had caused a costly mistake. Rather than the molten glass being poured out of the vessel, it had cooled slowly and solid, and James observed the glass formed crystals. This tied into an observation made by the German mineralogist Georgius Agricola, whose book on metals, published 200 years earlier, noted that valuable ores found in the ore mountains of Germany were associated with seams of quartz that he believed were once fluid and driven up by deep volcanic sources. So, during his 40s, James shifted from more playful, fragmented exploration to sustained and rigorous inquiry into geology as a subject. At 49, James set off to the Highlands on horseback and stayed at the invitation of the Duke of Atholl of Glentilt with his friend and thankfully talented artist John Clerk. Now, it was quite the fashion for the nobility to invite thinkers and scientists to their castles for conversation and to offer hunting, shooting and fishing in return. Now, 8 miles up this valley is the site of the shooting lodge, and here James made an exciting discovery, supporting his theories of Plutonism, and thankfully John Clerk was there to record it as an illustration. James was multi-talented, but writing was not one of them. His ideas were not projected well with his clunky writing style, and it's the reason why his books didn't really get the appreciation at the time. John Clerk, however, did have a gift of communication. Now, James observed in the riverbed granite intruding into the sedimentary rock. Therefore, the granite was once liquid. We now know that Dalridian rock is metamorphized sedimentary rock that dates from about 500 million years ago, and the granite is younger, some 390 million years ago. In the following years, James and John were to visit Arran. looking for more evidence of granite as an intrusive volcanic rock. But they came across a curiosity, an unconformity. Ancient metamorphized sedimentary rocks with strata has been pushed up, and then a slightly tilting, later carboniferous sandstone laid on top. James never wrote about his thinking of how he made big conclusions, but we can surmise that he considered volcanic forces were at work pushing up the seafloor into mountains and buckling sedimentary strata, and that this process, rather than being a cataclysmic event in the past, was a continuous process. The unconformity demonstrated that an ancient seafloor had sediments laid horizontally on it, then forces then pushed up and distorted the strata, and then this had been levelled again with erosion, and then a sediment of sandstone had then been deposited on top after the lower rock had been eroded away. James had lines of inquiry to disprove Neptunism and to offer evidence to prove Plutonism. But old ideas were entrenched in scientific and religious thinking. He needed a lot more evidence before he could make his case. Not far from his family farm at Jedburgh, the River Jed cut into a cliff, and in James's time the strata was visible. Now, we don't know if this rock formation had sparked his curiosity when he lived in these parts, or if he recalled the cliffs when he was looking for evidence. But here we have vertical greywacke, which is a rough, dark form of sandstone and shellbed, below a horizontal red sandstone, with a conglomerate layer in between. Now, this showed multiple cycles of deposition, uplift, erosion, and renewed sedimentation, implying vast time intervals. James, in collecting evidence across Scotland, complained of travelling and his sore arse from so much horse riding, and ironically, it was a local rock formation, an Arthur's Seat, at Edinburgh, that offered conclusive and convenient evidence. Hutton noted volcanic sills, such as the dolerite sills and Salisbury crags, intruding into sedimentary layers. Sadly, the instability of these cliffs means that the public cannot access the spot. But here the evidence is clear. Volcanic fluid or rock worked its way into sedimentary layers. But James wasn't done. With the aid of his friends, the 40-year-old John Playfair, he set about proving the Earth was ancient and formed by a constant process of erosion, deposition, and uplift, an eternal cycle. Now, one of the techniques they used was to follow stone walls, farmers gathering local rock as they found it, and a change in the wall from one rock to another would indicate a rock boundary, and it was in 1788 that the most important discovery for modern geology was found here in Berwickshire on the coast at Sicker Point. And it's quite the climb down, following the footsteps of numerous other geology students. Greywacke is a coarse sandstone with bits of mudstone. It was laid in deep coastal waters of the microcontinent that carried England and southern Ireland, Avalonia, and it deposited a thick sediment in the Iapetus Ocean that separated Avalonia from the continent of Laurentia, which carried Scotland, Scandinavia, Greenland, and Canada. Now, during the Silurian period, some 430 million years ago, the collision between these two continents pushed up the Caledonia Mountains and this seafloor, buckling the rocks into a near vertical strata. Over a period of 65 million years, this uplifted land eroded. The softer silts and sediments are eroding away faster than the sandstone. 375 million years ago, the great mountain range of Caledonia eroded away, washing rivers of red sand, forming a deltic-like landscape. The unconformity is the missing 65 million years. Now, James knew nothing of this. Plate tectonics and accurate dating were only accepted in the 20th century. What he did correctly observe was that this process took an almost infinite amount of time. In 1785, at the age of 59, he felt able to present his ideas as the Earth as a system to the Royal Society of Edinburgh. And the presentation bombed. He was accused of being an atheist, and Hutton's theories were not accepted in his time. And it would be years later when his full genius was fully appreciated. It was his friend John Playfair who helped him discover Siccar Point, who was to popularise Hutton's discoveries in 1802. His contribution is immense, and to a lot of science, not least evolution. Charles Darwin would not have made his leap in science without deep time and the ability to peer back into forever. I would have really enjoyed the company of James Hutton, not just for his sharp wit, jokes, and fondness for a good drink, but for the profound sense of wonder he carried, a sheer curiosity and a revolutionary spirit that challenged the established views of his day. And it's a spirit that drove him to explore the rugged beauty of Scotland in search of evidence. Now, without a time machine, I can only imagine the journeys and the conversations one might have trekking through the glens and coasts, and pondering the great mysteries of Earth, time, and nature's cycles. But in walking the paths he trod, and learning from his work, I found great pleasure, not only in uncovering the man behind the science, but in experiencing the extraordinary world of geology, the deep time story that Hutton opened up for all of us. So I hope you enjoyed this video. Do subscribe, like, and comment.